Einstein, you talked about Einstein. You talked about Newton. Newton was right, but Einstein had to fix his law, right? Like even Einstein. So that was an accepted. It was accepted, right? I'm just pushing you a little bit on.
Okay, so here's how that goes. So that's another aspect, a nuance of it that I'm glad you mentioned.
Okay.
So Isaac Newton, my man. Okay.
No, you're a fan.
Just to be clear, he's my man because he discovered the laws of optics and the laws of motion and the laws of gravity, and practically on a dare he invents integral and differential calculus. Then he turned 26. Okay. So are we done here with that? Do I have agreement here? All right. So he comes up with his laws of motion and laws of gravity, and they apply to everything he had ever seen or measured. Although the fastest anyone had ever moved might have been a galloping horse in his day. But it explained the moon going around the Earth and the Earth going around the sun. And it would later explain Jupiter's moons going around Jupiter. So it wasn't just a law of things that went around the sun. It appeared to be kind of universal in the literal use of that term, as opposed to how that word is used so often in our culture. Miss Universe. She's Miss Earth, please, all right? Okay? So what we later learned, as our methods and tools become more and more precise. I have to slip something in. Can I slip something? Okay, so watch what happens. So we apply Newton's laws, and we apply them to, William Herschel discovers planet Uranus by accident. Okay, Uranus is the planet just beyond Saturn. So by accident. And this is after Newton's laws of gravity are published. So now we're tracking the orbit of Uranus. You say, no, this is not following Newton's laws. It's got some deviation. So maybe we found the limits, the distance limit over which Newton's laws would apply. That'd be interesting. Mm-hmm. But other people said Newton was so badass, it must work, okay, even there. So instead of suggesting that his law was failing, clever people said maybe his law applies, but there's yet another planet out there that we've yet to discover whose gravity is tugging on it, and we did not include that in our calculations. So let's do the math and ask, where must there be a planet of what mass to create the deviation that we measure? And those calculations were done, and they were published, and an observatory in Germany got hold of those calculations, and they looked in the exact spot of the sky that the calculation said Neptune was waiting to be discovered right there. It was a triumph of Newton's laws. And so this gives us confidence. We're not just pulling this out. We calculate this, and the observations show it. So now watch what happens. We have better and better measurements, and we find out Newton's law is failing. Mercury's orbit is not following what it should. That's the closest planet to the sun. Well, we've been down that path before. Just throw in another planet that we can't see, and that'll fix it. So, thus was introduced planet Vulcan. This would be a planet very close to the sun, so close it would be hard to see, it would be lost in the glare. And so there was the hunt for Vulcan. No one found it. But we knew it had to be there, because that's the same problem as the discovery of Neptune. Einstein comes along, comes up with his theory of motion and his theory of gravity, the special and general theory of relativity. Out of those two theories, which are corrections to Newton's laws in these extreme regimes. If you're near the sun has very strong gravity. If you're moving around in that strong force of gravity, Newton's laws begin to fail. And no one knew this. And you look at Einstein's laws, and he says, Mercury's orbit will not follow Newton's laws, it'll follow this other path. Find out. And it exactly explained the deviations of Mercury. And so people say, oh, see, scientists, we thought this was right, and now we all huddle around this thing that's right. No, that is not how it works since 1600 onward. The way it works is if you have an experimentally determined result, and it's verified, and double-checked and triple-checked, That will not later be shown to be false. What you can find is a deeper understanding of the world that encloses that understanding. And that's what happened with Einstein. Einstein's theories of motion and gravity, if you put in low speeds and low gravity in the equations, they become Newton's equations. So Newton's universe is a subset, an accurately described subset of a larger universe that Einstein has described. And even with Einstein, his equations can't take us to the center of a black hole, the singularity that's there, the singularity at the beginning of the universe. We know now that his theories fail. They blow up on the page. So we have a whole frontier of science. The string theorists, you've heard of them. The string theorists, we got top people working on this to try to extend Einstein's laws into an even bigger regime that can then explain everything that's in our universe, not most things.
So what you're saying is that human activity is causing the planet to warm.
Yes. No, what I'm saying is emergent scientific truths assert this. And if you want to deny that in a free country, go right ahead, but you should not be put in control of anything that involves the Earth.